Hi, this is Dr. Bay, and here's Bugsy, and today we're going to go over the IUPAC rules of organic nomenclature. We'll delve into specifically how to name cyclic molecules. Stay tuned.
Organic chemistry,
taught by Dr. Bay.
reaction mechanisms,
Reactants to products.
retrosynthesis,
Target deconstructing.
molecules, spectroscopy, soaring through the sky, triumphantly we fly, give rise to the complexity of life, living on a dream across the seven seas, learning about spectroscopy. Organic chemistry.
So if you watched the video on naming acyclic molecules, this one will just be slightly different to accommodate for cyclic molecules instead. So save both this chart on functional groups and the next chart on functional group priority so we can learn about cyclic molecule nomenclature. The first step of naming a molecule is to determine the primary functional group. Again, molecules with single bonded CC or CH bonds do not have functional groups, so alkanes will have the suffix or ending of ane, just like the molecule on the right. When there's more than one functional group in a molecule, the group with the highest priority is usually the more oxidized one, which then determines the suffix. In this example, it contains both an alcohol group and a ketone. So if we refer to the functional group priority chart, we'll see that ketones have higher priority than alcohol groups. So the ketone will be our primary functional group, giving our molecule a suffix of -one, while the alcohol group will give us a prefix of hydroxy. If your molecule has alkenes or alkynes, they're only written in the suffix. If there is a higher priority functional group present, the alkene or alkyne should be written after the root of the name and before the suffix of the primary functional group. For example, this molecule has both an alcohol group and an alkene, so the alcohol has the higher priority than the alkene, so the suffix will be enol. Step 2 is to determine the primary carbon chain. When the primary functional group is on a cyclic carbon chain, identify the ring as the primary carbon chain. So in this example, the first molecule on the left, which includes the alcohol group, is the better primary carbon chain since it also includes the ring, rather than the second molecules that exclude the alcohol group and ring, even though it's a longer carbon chain. Step 3 is to name the primary carbon chain as well as the primary functional group. To do this, you're going to give the same name to the chain as if it was an acyclic alkane, but we're going to replace the ending ane with the suffix attributed to the primary functional group. And since it is a ring, we're going to add the prefix cyclo to the name. And just for your reference, a table of parent names for alkanes is shown on the right side in orange. In this example, the ketone is our primary functional group and the rest of the molecule is a cycloalkane. So it will have a root of hexane, where hex stands for 6 carbons and the an is for the alkane, and the ketone is our primary functional group, so we'll use the ending -one. So together, the molecule's name is cyclohexanone. Step 4 is to number the primary carbon chain such that the primary functional group is on the lowest number possible. So when the ring is mono-substituted, the carbon bound to the primary functional group will always be on the first carbon, or C1, so there's no need to indicate its position. However, when a cyclic chain is polysubstituted, the direction of numbering is determined by ensuring the lowest possible numbers are given for substituents. The primary functional group is bound to C1, and numbering will continue in the direction of the lowest numbers for all of the other substituents. So in this example, the left molecule is better because the methyl group is on C2 rather than in the right molecule where the methyl group is on C6. So when naming a cycloalkene, where the alkene is the primary functional group, the alkene will be on C1, and it's not necessary to include the position in the name. When a functional group of higher priority than an alkene is present, the carbon bound to the primary functional group will be C1, and the numbering continues in the direction of the lowest possible number for the alkene. So in this example, the primary functional group is the alkene, so the left molecule is better where the chloro group is on C4 rather than in the right molecule where the chloro group is on C5. Step 5 is to indicate the position of the primary functional group. But for cyclic molecules, since the primary functional group is always on C1, it's not necessary to indicate the position in the name. But the position of all of the other functional group substituents must be indicated. So step 6 is to then name the substituents. Alkyl groups are substituents that take on the ending YL. And if you have more than one of the same substituent, remember to use multiplicative prefixes, which again have no effect on alphabetical order. So in this example, the primary functional group is the ketone, so its suffix will be ONE. The cyclic molecule has 6 carbons, all of which are single bonds, so it will have the root of cyclohexane. And the substituents bromo is on C2 and chloro is on C6, so its final name will be 2-bromo-6-chloro-cyclohexanone. And lastly, step 7 is to assemble the entire name by writing out the numbers for the substituents listed in alphabetical order. So separate the position of substituents using commas, and then use hyphens to join the name to the numbers. In this example, the primary functional group is the carboxylic acid, shown in blue, and we're going to number the molecule such that the alkene is on the lowest possible number. So we're going to count counterclockwise around the ring. And there's also a chloro substituent at C6 and 2 ethyl groups at the C4 and C5 positions. So its final name will be 6-chloro-4,5-diethyl cyclohex 2-enoic acid. So in summary, the IUPAC rules of organic nomenclature include Step 1, determine the primary functional group. Step 2, determine the primary carbon chain. Step 3, name the primary carbon chain. Step 4, number the primary carbon chain. Step 5, indicate the position of the primary functional group. Step 6, name the substituents. And finally, Step 7, assemble the entire name.
Organic.